sir, what we are discussing today?
Hello. Hello. Can you hear me?
Yes, sir.
Okay. All right. Great. So today's session is about doubts from week 10. Okay, so any one of you is having any doubt from week 10, so you can raise your hand and we can discuss. So anything like any concept or any question.
A discrete uniform variable.
Okay. You got the idea of discrete random variable?
Yes, sir. I think so.
Okay. So uh, just to know your thought, what is discrete random variable?
Excuse me, sir.
Yes.
Sir, shall I post the questions in the chat box?
So where is from? It's from AQPAJ. You can let me know. We can discuss. That's not a problem at all.
No, I have doubts from practice assignment.
Fine, we can discuss questions from practice, and that's not a problem.
But in practice question assignment, we have different questions.
Okay, all right. You can post. No problem. We can discuss. Okay. So I think someone was saying something. Yes, please go ahead. So, what's your thought on discrete random variable?
Mm, sir, I'm thinking.
Yeah. Okay. All right.
Sir,
So
is
what?
this session recorded?
I think it's streamed, right? No. Let me check.
Sir, can I ask my question?
Yeah, it's recorded. So streaming is going on. Yes. Yes. Please go ahead.
Sir, in uh, 1 minute.
Mhm.
Sir, in Bernoulli trial,
Mhm.
we calculated expected value, right?
Correct.
So in that in that lecture, we have taken as means the probability of 0 as
Mhm.
1 minus p and
Mhm.
probability of getting 1 as
Mhm.
p.
Correct.
So the expected value we means we computed and we got p.
P. Correct.
So if we interchange that, like 0, if we put 0 as p and
Mhm.
1 as 1 minus p, so
Mhm.
we will get minus 1 minus p.
Mhm.
So like how can we compute like what?
No, no. So the thing is, see, basically, zero means what? So suppose, see, if whenever you are doing Bernoulli trials, let me share my screen. Okay, this white PDF is visible to all of you. Can you
Yes.
see my screen? So whenever is there any Bernoulli trial, right? So what happens in case of Bernoulli trials? So for each trial, there are two possible outcomes. Okay, only two possible outcomes. So first one is it's called success, and another possibility is failure. Okay.
Yes, sir.
Now, so this success, see, success means for the kind of you can consider as a what do you want, like your objectives. For example, suppose you are tossing a coin, right? And you are interested in head. Okay, to know whether a head appears or not. So head, if you suppose you toss a coin, if you are getting head, then it will be your success. Otherwise, it's failure. Okay, so there are only two possibilities. And for success, we are denoting as one, and for failure, it's zero. So for success, we are taking success probability as a p. And then since there are only two possible outcomes, so as per the law of this probability axiom, if you see, so it should be 1 minus p, right? Because sum of all the probabilities should be equal to
1.
1. Correct? Now, so this is the case. So, for example, suppose you have a fair coin. Okay, so if you have fair coin, then what will be the probability of getting ahead? It's 1 by 2,
Yes, sir.
right? Then suppose this is P. What will the probability of getting a tail? Miss for your failure. It's 1 minus 1 by 2, which is
Half.
half again. Correct. So it depends. Suppose, see, it's possible. Something you can consider a result of exam, right? So the result of exam, and so what will be two possible outcome? Either pass or fail, right?
Yes, sir.
So suppose there is a you can consider something like this. Suppose there is a possibility of a student, he or she is giving a particular exam, and probability of passing that exam is, let's say, 0.6. Then what will the probability of he or she will fail in that exam?
0.4.
0.4, right? So that's the thing. Okay, even you can consider, you can define, let's say, this is, if this is the 0.4, then this will be 0.6. That's all.
Okay,
So
so we
whenever
can interchange.
interchange, that's not a problem. It depends on your objective or your past experiences. That's all. Okay.
So
Sir,
both
if we are considering the output as success or failure in this Bernoulli, then
Hmm.
what is the difference between Bernoulli and that binomial distribution?
See, binomial. Okay. So let me tell you. So suppose, okay, for example, I'm tossing a coin first time. Okay. So I will get two outcomes. Let's say I'm denoting as a x1 random variable. So this will either will be a success or failure. Let's say I'm interested in head or tail. So far so good. Now, suppose I'm tossing a coin again, second time. Again, I may get 1 or 0. Yes or no? These are two possibilities. Suppose you are tossing the coin third time. Again, you can get 1 0. It will be head or tail. And up to, suppose I'm tossing this coin tail 10 times. Again, I have two possibilities for this 10th toss, head or tail. Okay, so far so good. Okay, is
Yes,
this
sir.
clear till now? Right? So far this is fine. Now, what is the binomial actually? So this is something, I will say, this is something I have xi, and each xi follows Bernoulli with, let's say, success probability half. For example, just assume. I mean, this is, suppose this is a fair coin. So
Yes,
what is here? You are having 10 Bernoulli trials. Okay. Now, what is the binomial? So binomial is nothing but, and see, if you are tossing the coin, then outcome at the second toss will be independent of the first toss.
yes,
Similarly for third toss, right? Again, outcome of the 10th toss will be independent. So basically, each trial is independent.
yes,
Yes
sir.
or no? Right. So what binomial says? So binomial is nothing but it's sum of n independent Bernoulli trials.
Okay, okay.
Okay. So what it will give you? So basically, if I will talk about in general here, in this case, let's say, suppose it will be summation I is equal to 1 to 10. This is xi. So this will follow binomial, and with parameter. So what is the number of trials? 10. And what is the success probability? It's half.
Half.
So now what binomial? So let's say I'm defining as a capital X. So what is the capital X? Capital X will represent. Uh, so basically, this capital X will represent number of heads in uh, in this experiment, in this 10 tosses trials. Understood? So Bernoulli is single trial, and binomial is the binomial is nothing but sum of n independent Bernoulli trials. So just keep in mind, this should be n independent, right? If there is dependency, then there is something called hypergeometric distribution. I mean, you will see in week 11, if I'm not wrong. All right, clear?
Okay, sir. Thank you.
Yeah.
Sir,
Hmm.
about the discrete random variable, sir, it's
Hmm.
a variable which can take only discrete values.
Discrete values, correct. So you were asking about discrete uniform distribution, right? Okay, so
Yes,
anyone
sir.
of you wants to say something about this discrete uniform distribution? Please go ahead. It's not any uh, something
The
you'll get
discrete variable.
penalty. Hmm.
So discrete random variable you are asking for?
So actually, Meghna wants to discuss about what is the discrete uniform distribution. So if any one of you wants to say something, please feel free to say. So this is just discussion session, doubt session. So whatever the things you know, just you can explain. So it will be interactive session. That's not a problem. And there is nothing, any penalty, something you will get penalization of. So whatever the things you know, please share.
The
Okay. So
outcomes
anyone?
are equally
Hmm.
likely in this case.
Okay. Great. For anybody else? No one? Yeah, so in case of discrete uniforms, if you see word uniform, right? So it will take probability will be uniform. It will be same probability. That's see. I think Varun said correct if I'm not wrong. So outcomes are equally likely. So what is the meaning of equally likely? Suppose I'm saying I have defined my random variable x. Okay. Okay. Tell me if you are rolling a fair die. Suppose. Okay. Then what will be my x random variable? What will be the possible outcomes if you are rolling a fair die?
1, 2, 3,
1
4,
to
5, 6.
6.
1, 2, 3, 4, 5, and 6. All right, great. So what will be the probability you will get 1,
1 by 6.
2,
All 1 by 6.
1, all will be 1 by 6, right? So if you see, what is the probability for each outcome? This is same,
Yes,
right? So this is uniform or not? Correct.
yes,
So
sir.
for each outcome, the probability is same. It's uniform. It's a uniformly distributed, right? So there is no change in the probabilities. Okay. And so basically there is another word is called equally likely. So equally likely means whatever the possible outcomes of your random variable is there. So all the probability will be probability will be same for all the outcomes. Okay. So this is called discrete uniform. If you want to generalize in case of n, so I will say x is taking values 1, 2, 3, 4, let's say till small n. Then what will be the probabilities for each value? It will be 1 by n, 1 by n, 1 by n, 1 by n, and till 1 by n. Okay, it can be something like that. X can be 1, 2, 3. Success probability are let's say 1 by 3, 1 by 3, 1 by 3. Your random variable x can be something like this 4, 5, 8. And success probability, this probability with each values is 1 by 3, 1 by 3, 1 by 3. This is again discrete uniform distribution. Okay, so if you see this probability should be same. Okay, if you want to draw PMF table, PMF graph. So this will be X and this will be probabilities. So let's say 1, 2, 3, 4, 5, 6. And suppose this is 0 and some 1 by 6 somewhat here. So you will see this height of bar will be same. It will be uniform. There is nothing change.
Sorry, sir, but for 4, how 1 by 3? Am I something missing?
This is just a random example I took. This is
Okay,
not.
okay.
This is something X is taking is possible. It's possible, right? X taking values 4, 5,
So it's
and
an
8.
example, right?
It's just example. This is nothing related to the previous. This is another example. Okay, and this can be any. You can define any random variable x with any objective, and then x is taking value 4, 5, and then probabilities for each value. This 1 by 3, 1 by 3, 1 by 3. Okay, this is just a random hypothetical example.
Yes, sir. Okay, sir. Thank you.
Clear? Yeah. All right. Yeah. Yeah. Anybody else?
Sir, all the probabilities are independent.
Here. So it's equally likely, right?
Yes,
If there is dependency, this okay, tell me whether if there is dependency, probability will get changed or not. Just think of it. I can give you right answer right now. Just I'm leaving on you just to think of it. If there is a dependency, will the probability will change or not? So Varun is sending something. I don't know. Yeah, we'll come to that point. I think you can ask about.
Doubt.
Yes. So Varun, you are having doubt in this question, right? A coin is biased such that head is likely to occur 4 times than that of a tail. Find the expected number of heads when the coin is tossed twice. Okay, this question is on the portal, right? Uh, is it is this case same for everyone? After refreshing, we are getting different question or yes, no?
If I refresh the page, it comes another question, different questions. Right.
For week 10, I don't think this should be the case. Okay, anyway, this is the question, right? You are having doubt, right?
Yeah, yes.
Yeah. So, how many questions you are able to see on your portal? All questions or
7 questions I could see.
7 questions? Only? Okay. Okay, no problem. So, okay, so if you see on, if you have seen this feedback we have pasted already or not? You haven't gone through that? Arun, Varun, can you hear me?
Can I explain the solution?
Yes. No, no, no. So what I'm saying, have you seen the feedback or have you gone through the solution anytime or not?
Yeah, yes, sir.
Still you didn't get, right?
I can understand the equation 5.
Equation 5. Okay. So see, a coin is biased such that head is likely to occur 4 times than more than that of a tail, right? Okay. So first of all, this first equation is okay.
Yes.
Okay, right. Now, if you see the second equation, so there are only 2 possible outcomes, right? Either you will get head or tail.
Yeah, we are using a Bernoulli's variable theorem.
Okay, so anyway, if you have if you are tossing a coin, right? So there are only 2 possibilities, right?
Yeah, yes.
Okay. So and there are and both outcomes are disjoint to each other. Yes or no?
Yes.
And we know if both 2 outcomes are disjoint to each other, let's say probability of, and there won't be anything common, then this will be 0,
Yes.
right? What would probability of A union be? This is probability of A plus probability of B. Can I write or not?
Yes.
So that's also. So that will be probability of A. That is probability of head and probability of tail. See, basically you can see you have tossing a coin. Okay, let's say you are tossing a coin. You may get let's say head or tail, right? And some numbers you can assign here, and it's a biased coin. So this success probability is, let's say, P, and this is 1 minus P. Bias means this it's not fair. Fair means you can say getting head or getting tail. Probabilities for getting head and probabilities of getting tail, these two are not safe. All right. So if you apply the property of valid PMF, so addition of these two should be 1, right? So probability of getting head plus probability of getting tail is, that's all. Now is it okay?
Yeah, okay.
Yeah. I think other calculation is fine, or should I explain?
Yeah,
It's
it
fine,
is
right?
understood. Yes.
Oh, all right. Yeah, great.
Sir, if you can explain just, can we go through this table once, 0, 1, and 2,
See, you are tossing the coin how many times?
2 times, like we want to find the answer.
Right, twice. So what are the possible outcome? Possible values your random variable can take? 0, 1, 2.
0.
Right? That, see, 0 means you can get 0 at one head, and 2 means maximum you can get 2 heads. That's all, right? And if you say probability of x equal to 0, when if you are getting 0 head, that means
We're getting tails 2 times.
tails, right? 2 tails. And what is the probability of getting a tail? It's 1 by 5
1 by
and 1 by 5. So 1 by 5 into 1 by 5. If you are getting one head means what? Head, see,
1 head, 1.
See, you are getting one head, so one head means what? So basically, you may get head at the first toss and tail at the second toss, or tail at the first toss and head at the second toss. Would you agree with me?
Yes.
Right? So that's the case. So you have to find out the what is the probability of head, and which is basically 4 by 5. So it will be 4 by 5 into 1 by 5 plus probability of this will be 1 by 5 into 4 by 5. Okay. And if you got the two heads, that means head at the first toss and head at the second toss. So it will be 4 by 5 into 4 by 5. So now you have to apply the uh, formula of expectation. So expectation is nothing but it's zero, I mean summation of x into your corresponding probabilities. So 0 into 1 by 25 plus 1 into whatever that value and plus 2 into that 16 divided by 2. Okay. Is this clear?
Sir, I have a question. Sir, in the question it's written that so can we see the question? Yeah. Find the expected number of heads. So, sir, if it is written expected number of heads, that means it's asking us to find the expectation of getting head.
Correct,
Is it?
correct.
Okay, okay. Okay,
Okay.
sir.
And x will represent the number of heads you will get. I mean, whenever you are going to toss the coin two times, so x will represent the total number of heads. So it may one, you may get one, you may get zero, you may get two also. Okay.
Yes.
Yeah.
Excuse me, sir.
Yes.
Sir, I have sent the doubt. Could you please clear it?
Okay. I think I will go one by one.
Yes, sir.
Okay. Let x be how much you win in rupees in a lottery, and the lottery we draw a random number which is between 1 and 1000, and the price is this assume. Okay, so find the expected winning. Okay, so Varun, have you seen the first part of this also, or
Yes, sir. They have taken the probability. They have find out the probability of each
okay, okay,
outcomes.
let me see where this question is.
Sir, which question number is it?
I don't know. I'm just searching that part. See, if possible, I will explain from the solution itself. That's what I'm just. Where is this question? Okay, this question, right?
Yes.
Question number 4.
Yes. Okay, so if you see, it is also mentioned each outcome is equally probable. So what is the meaning of equally probable, first of all?
So equally likely, so uniform distribution.
Okay. Okay, Varun. So if you see, each outcome is equally probable. So probability of getting number will be same for all the number, right? Okay. And what is the values your random variable x is taking here? Is taking what is the possible values of x here? 0, right?
0, 4, 10, 100, and
Okay, so
1000.
x is taking. So there are some conditions, right? X will take value 0 when your small x, basically x is representing the how much money you are going to win, right? If you're if suppose you win any money between 1 to 700, x will take 0, correct?
Yes.
Right, that's the this
So what is
uh,
capital X here?
see, capital X is your how much money you win in a lottery. Okay, so basically it's a kind of random number. Okay, suppose any random number you are getting between 1 and 700. Sorry, there was confusion earlier. So if you are getting any number between 1 and 700, you will get 0 rupees. Okay, if you are getting any number between after 700 and till 950, you are getting you are going to win 4 rupees, and similarly 10 rupees, 100 and 1000. Okay, so it is asking what is the expected winning. Okay, so if you say first of all, so from here, if you, x, what is the probability of x will take value 0? Okay, let me write. Can you tell me this conditions 1 to 700, right? And then 4 after 700 till 950, and 10 950 to 990, and then 100 after 990 till I think 999,000 and 999 to 1000. Okay, so far so good. Now, if you see, it is saying each outcome is equally likely. So, first of all, what is the possible values your x will take? 0, 4, 10, 100, and 1000. So, these all are rupees, right? If you are getting any number in this, which is satisfying this condition, you will get 0 rupees. If any number which satisfies this condition, you will get 4 rupees. Okay, something like this. So, what is the probabilities? First of all, what is the probabilities you will get 0 rupees? Tell me. If, if you are getting any number from 1 to 100, 1 to 700, right? No, for 0. For 0, I'm talking about. When you will get 0 rupees, if you are getting any number between, I mean, from 1 to 700, right? So you have 700 possibilities here, yes or no?
Yes.
Yes, sir.
And in the question, it is simply written each outcome is equally probable, right? So what will when you what will the probability your x will take 0? It's you have what is the favorable cases here? 700 and total is 1000. This will be the probability. What about probability x equal to 4? Tell me how many numbers are here?
250.
250, right? So basically, what is the meaning of this probability of x equal to 4? Means suppose you are getting any number, let's say 800, you will get 4. If you are getting 805, you will get 4. If you are getting 701, you will get 4. I mean, you will win 4, right? So basically, you have 250 possibilities. Yes or no? So it will be 250 divided by 1000. Similarly, it has been done for probability x equal to 10, probability x equal to 100, probability x equal to 1000. Okay. What is the for probability x equal to 10? It's 40. And probability x equal to 100, it's 10. And then 1. Okay. So those are the possibilities. Sorry, it's not 10, it's 9. Because it's 999 to 990 only. Correct? So now, as usual, you have to apply the formula of expectation. So what will be expectation now? Expectation of x will be, since this is the discrete, so summation of x into probability x equal to x. Basically, it will be 0 into this probability 700 divided by 1000 plus 4 into 250 divided by 1000 plus 10 into this corresponding probability and so on till 1000 into whatever the answer. Okay, is the idea clear now?
Yes.
Okay, yeah. So I think you can tell me the question number, right? I have to see the questions again, and you are simply taking the screenshot and posting on the chat, right? So simply tell me the question number or question I can see on my, so that's not a problem. Okay, range of a random variable x is the is this from practice assignment? Yes or no? Is this from practice assignment? Let me know. I have all the questions. I will see.
No, sir, it's not from practice.
It's from where?
Sir, it's from Solve With Us session, but the approach given by the madam is not clear.
Yeah, is it? Have you seen the solution video? You went to the solution
Yes,
video?
sir. Sir, in that,
Yeah, go ahead, go ahead.
no,
What
sir,
you
this
got?
is not my question.
Who posted this
Sorry,
question
sorry,
then?
this is not.
Okay, Meghna is having doubts. Two cards are drawn simultaneously from well separate. Okay, this question is from 9.1 question 4, right?
Yes, sir.
Okay. Okay, what was your let's
Sir,
see
I understood that.
where it went?
Mhm. So, sir,
Okay,
two cards we are drawing.
no,
Hello.
no. One second. Let me see the question. Yes, yes, this question, right? Yes, yeah, go ahead.
Eh,
Yes, yes, go ahead, go
Hello.
ahead, go ahead. Yes, yeah.
Sir, two cards we are drawing.
Mm-hmm.
And the face cards will assume number 10,
Mm-hmm.
10 points.
Mm-hmm.
And 10 number card will also have 10 points.
Correct.
And rest all the cards will have their own numbers, and
Mm-hmm.
ace will have number 1.
Mm-hmm.
So minimum we can get is 2, because 1 a plus a. And maximum we can get 2 face cards, or maybe face and 10. So
Mm-hmm.
maximum we can get 20. That I have understood. But sir, when it is saying how many outcomes will this result x equal to 19?
19. Hmm.
So for 19, what my thought was that okay, we can get one face card
Hmm.
and one number 9,
Okay.
or maybe a number 10 and then number 9. So there has to
Hmm.
be one number 9, and then we can have a pool of face card and number 10. So we can have 12 face cards and four of number 10. So total of 16 cards are possible, which will give me 10 points. And then for number 9, I have only 4 options. So, sir, I'm not getting how this 64 is coming.
Okay, see, first of all, you have one card. Okay, how many cards with number 9?
Hmm,
One card. Okay.
one card, yeah.
How many cards with number 10? One with 10 and three with for face cards. I think there
Yes,
are
sir.
three face cards. Okay. So there are total, you are having how many, this, uh, what to say? Total four, right?
It's a 4 different,
Four
yeah,
different, yeah, four
cards,
different
yeah.
10, right? Now, for how many different suits are there?
4,
Four, right? Okay, third and fourth, right? Now, tell me, in each suit, first of all, what are the possible ways you will get 19? So you may get 10 plus this one,
yes, sir, 10 and 9, yeah.
then 10 plus. Basically, what is the total number of ways you will get? 19 in the first.
So we are taking only 2 cards. We are drawing only 2 cards. So suppose in the first draw we got either a face card or number 10.
Either a face card or number 10.
So I have
See,
16
two,
options.
you have 16 options, right? In
Yes.
each suit,
Yes.
right? 16 here.
Not in each suit, because
Hmm.
I have 4 queens, 4J and 4K
Hmm.
from all different suits. So that has made 12 cards. And then I have 410.
No, no, don't go like this.
Okay.
See,
Yes, sir. That's why my approach is not correct. So please.
first of all, 9 cards. Okay, what are the possible case? See, if you see, there are total three face cards, right? How many nine? See, you are having two, three, up to 9, correct? These are
Yes,
the
sir.
numbers card, right? And sorry, 2 to 10,
Yes, sir.
correct?
And the
And
one also, because ace is not taken as a
ace,
face
ace,
card.
ace is one, right? Now, and another three cards, king, queen, jack, correct? This is 10,
Yes,
this
sir.
is 10, this is 10.
Yes, sir.
Okay. Now tell me, in how many ways you will get, okay, first of all, to get 19, what are the possible ways?
And 10 points.
Okay. Right. That's the correct thinking. Now I'm asking
Okay.
in how many ways you will get for the first. See what I'm trying to say here. Let me write those part. Okay. So suppose to get 19, I may have 110, right? Yes or
Yes,
no?
sir.
Yes or no?
Yes, sir. Yes, sir.
110. Let's take 110 and 9 from each different suits, right? Let's say
Okay.
one 9
Okay.
is from club, one is from spade, and one is from uh, hearts, and another is from diamonds. Okay.
Yes, sir.
Okay. Now, in how many ways you will do for this case? What is the total ways?
Four times we have to do this.
4 times, right?
Yes, sir.
See, just think of it. I'm just
Yes, sir. In that case, 16
hmm,
into 4 actually.
16 into 4. That's what I'm trying
Yes,
to say,
sir.
actually.
Yeah, yeah,
Right?
yeah. Yes, sir.
Understood?
Yes, sir. Yes, sir.
Yeah. Yeah. So
So, but
whenever
then,
you are
yeah, so this I have understood. But sir, won't we then shuffle? I mean, then we can have 9 in the first place, and then we can have a 16 cards
no,
in the
no, no, it's
second.
not about, no, it's not about like that. So basically,
Okay.
you should see X represent the sum of both cards should be 19.
Yes, sir.
Okay,
Okay,
that's the
sir.
matter.
Yes.
That's not.
Yes, sir.
Okay.
Yes, sir. Yes, sir.
Oh,
Yes, sir. Okay, sir. Thank you, sir.
I think this is done. Week 9 graded assignment questions. I think today's it's all about week 10 discussion, right? You haven't seen the solution of week 9 grade assignments?
Sir,
Hmm.
sir, I have a doubt in the concept. May I
Mm-hmm.
ask, sir,
Which concept?
if
Hmm.
x and y are independent, then
Hmm.
what is the value of var of 2x minus 3y?
Sorry, what is?
If x and y are independent, then what
Hmm.
is the value of var of 2x minus 3y?
It's not bar, it's variance of
Yes,
2x
yes,
plus
sir.
3y, right? And first of all, you should tell me what is the variance of x. Otherwise, you can't tell anything.
Oh,
You
sir,
are,
variance of x is, wait,
is this question from where? You can tell me that.
variance of y, no, no, sir, it's from a exercise,
Yeah,
book
that's what I'm
exercise.
asking.
Yes, sir. Sir, variance of y is 64 and variance of x is 25.
Okay, all right. So if you maybe you have seen what is variance of x plus y if x and y are independent. I can write variance of x plus variance of y. Yes or no?
Yes, sir.
All right. Now you have seen variance of, then tell me what about variance of ax plus by? I can write this as a variance of a times of x plus variance of b times of y. Yes or no?
Yes, sir.
Right. Another thing, there is property of variance. So variance of a times x, where a is a constant, I can write as a square variance of x,
Yes, sir. Yes.
right? So this will be a square variance of x plus b square variance of y, right? Same property you have to apply here. So it will be variance of 2x plus variance of 3y. In the question, it will be mentioned x and y are independent. Otherwise, you cannot write this variance of x plus y is same as variance of x plus variance of y. So this will be 4 times variance of x plus 9 times variance of y, and you have to just substitute these values. Variance of 4 into 25 plus 9 into 64. So just multiply this and these two and add these two. You will get the final.
Okay, sir. And sir, then what is the value of variance of x plus 4 where x and y are independent?
No, no. So if it's saying a variance of x plus 4, so there is no role of y, right? So it's the same as variance of x. Basically, you have seen in week 3 also. So if you are adding any, well, basically addition or subtraction, if you are doing, like if you are adding or subtracting any constant from the observations, then in that case variability don't change. Okay?
Then
Variability
the
is not
4
going to
part
change.
will be 0.
You can say yes. So variance of a constant is zero always.
Okay, sir. And sir, if x and y are not independent, then
Hmm.
is this in the syllabus?
No, it's not in syllabus, but I will tell you the formula. So if it's variance of x plus y, so it's variance of x plus variance of y plus 2 times covariance of x comma y. If it's minus, it will be minus. It's not in our syllabus. We are just going with this x and y are independent. So if x and y are independent, you may have seen if x and y are independent, then there will not be any relation in x and y. So in that case, it will implies that covariance between x and y will be zero. So this will be zero. So that's why that statement is there. If x and y, these two are independent, then variance of x plus y will be same as variance of x plus variance of y, because if these two are independent, then covariance will be zero. All right?
Okay, sir.
Yeah. Okay. Great. Okay. Anybody? Anything else?
Doubt in 9.1
So 9.1 question
question, sir.
4.
Yeah,
The same thing we discussed just right now.
sorry.
Okay. No, no, it's not about sorry. I think who asked that question? Can you explain, please?
So fourth one.
Yes. Can you explain the same thing to?
Yes, sir.
Hmm.
May I?
Yes, yeah. Please go ahead.
Sir, we are having 12 face cards. So we could select 12 C1 means one card we could select, which will give us 10 points. And other thing, we have to make 19, so 9 we have to add. So the 9 cards we are having are 4 in the deck of 52 cards. So from 9, we could means for from 4 cards, we could select one, which will give us 19. This is our first case. And from we can make second case also, which is we are having 10 4 cards. Though these 4 cards could be selected once, like a 4C1, and another 9 we have to add on to make 19. So we could similarly select 4 cards which are of 9 from the deck, 4C1. So 4 into 4 of second case will be 16, and the case 1 will give us 48. So the net will give us 64, and that current answer is also 64.
Yeah, basically you can think like this. So for each suit, it will be 16, right? If you have 10, 10, 10, right? So basically, and then for, then for 4 suits, it will be 16 into uh, 4, that will be 64. So that 4 comes, will come for each suit, there is only one possibility of getting 9. So for 4 suit, it will be 4. So that 16 into 4 will give you 60. Okay. Yeah. Anything else? Anybody? From
Sir,
week
I have
10,
a doubt.
you have yes.
I have a doubt from week 9 graded assignment.
What is your doubt? Have you seen the solution PDF? Have you gone through the
Yeah,
solution PDF or not?
yes, but I could not understand the second question solution.
Question number 2.
Yeah.
Okay, let me open the
Sir, before that, I have mentioned my doubt in the chat box.
chat box is bit. Which question?
So I have sent the image.
Which image? Where it's there? This one? This question you're talking about?
No, no.
Huh. That's all I can see if I'm not wrong. This one?
Okay, sir, I'm sending again.
This one you're talking about?
No, sir, I will send it again.
Which question you heard out? Question number?
Two.
Two. Okay. So, okay, first of all, if you see in an organization, Texas organizes lucky draw this month. Okay. So it's in general, right? So it's in general, like for different, you'll get different values. So, n thousand tickets are sold for $M each. Okay, and each has an equal chance of winning, and small x number of tickets will win $a, and y number of tickets will win $b, and z tickets will win $c. There is a random variable x which denotes the net gain from purchase of one ticket. Okay, so what is the probability that x takes value less than b? So it is asking what is the probability less than b, right? So b means if you see y tickets will win $b. First of all, what is the possibilities of x can take values? See, total tickets sold for $M, right?
Yeah, yes.
Right? You may lose all,
Yeah, minus M.
right? Then for
It is
A,
n. It is n minus m. They have mentioned only minus m in this case.
can take values, no, right? So, see, if you are losing all, see, if you're losing always, this N tickets is all about N thousand tickets, $M each, right? Not getting, right? See, if you see in the below one, and for example case, we have taken some values also. Okay, so suppose there are five tickets. Okay, 5,000 tickets.
Yeah.
Okay, so if you see 5,000 tickets, this 5,000 tickets, and M is all tickets of $1 each, right?
Yes.
And then small x is, let's say, one ticket is $1,000, and two tickets worth rupees $500. Okay, and 10 tickets of $3 means $100. Okay,
Okay.
now if x is less than 500, now what is the b? B is, I'm talking about 500. So what is the values here? It will be, if you are talking about less than 500,
F499
sorry,
should be less than 500 means it's 499.
499, right? And then x equal to 99. See, this will be minus 1, right? Because each, or you are losing everything, just suppose.
No, I thought that out of n,000 tickets, we are losing some $M, so I thought n minus m. So.
No, no, M dollar is the price of each.
Okay.
Okay, M is not a number of tickets. M is the price of each ticket. So basically, suppose you have n thousand tickets and $M each, then there will be how many in terms of, if you talk about this, what will be price, overall price? Yeah, tell me, go ahead.
Overall price 1,000.
No, thousand tickets are there. So $1,000, right? Yes or
Yeah,
no? Right?
$1,000. Yeah.
That's what I'm trying to say. Okay. Yeah. So basically, if you see these numbers, yeah. Okay. So this is 5. Okay. If you see this 5, and then how many tickets are there then? For 5,000 tickets,
Yeah, 5,000 tickets.
and each what is the worth of each tickets? Is $1. Then it will be $5,000 total price I'm talking about, right?
Yes.
Understood? So that's the case. Similarly, you can. Okay, got the idea?
Yes.
Uh, and there was any
Sir,
other
now
question,
as
right? Or that's all.
Yeah, 12 and 13.
12 and 30. Okay. Okay, so this question, if you see, there is six-sided die which is marked one on two of its faces. First of all, six-sided die will have six faces, right? Okay, and
Yes.
one mark on two of its faces, two on one of its faces. Right? Total three faces covered, and three on the remaining three faces. Correct? Now, die is thrown twice, and next, do you know the the total score in the two tosses? Okay, let's see. First of all, if you see, uh, if you see y equal to 1, so y equal to means y denotes the outcome. So number of faces 1. What is the probability of 1 here? First of all, you are what are the total cases if you are rolling a die? 6
6 cases.
6 cases, right? And one that number 1 is marked on two of its faces. Then what is the favorable cases for getting 1?
2 by 6.
2 by 6, right? And what is the probability for getting 2? Because it is marked on only one face, so it will be 1 by 6.
Yes.
And then similarly for 3, it will be 3 by 6. Correct? So this is for when you are rolling a die single time, right? If you are going to roll dice second time, since those two are independent, I can add both random variables. Right? Let's say I'm denoting as a y1 and y2. So this will be, I can denote, let's say y equal to y1 plus y2, or you can define x equal to y1 plus y2. Correct?
So
Are you
in
getting?
question, they have mentioned in independent throws. Is it understood that it is
No,
independent
no, okay,
throws?
okay. So if you are rolling a die twice, so first time, the outcome of the second time doesn't depend on the first time, right? See, rather than
Yeah. Okay. Okay. Got it.
it's the six phases. There are some different die, right? Okay,
Yes.
okay, that's all. So if you see probability x equal to 2, right? So since you are going to roll 2 times, you will get values from 2 to 6, correct?
Yes.
Right? Now, when you will get 2, when first outcome is 1 and second outcome is 1, that is probability y equal to 1 and probability y2 is equal to 1. And what is the probability of getting 1? It's 1 by 3 into 1 by 3, 1 by 9.
Yeah.
Clear? And similarly, what about probability x equal to 3? First die is 1, second is 2, or second is first is 2 and second is 1, right? Then since these two are I mean both are different, so basically we have to add, because it's or case, not and case. So we have to add the probability. So it will be 1 by 3, 1 by 3 into, for 2, we have calculated the values as 1 by 6, it will be 1 by 6 plus
So
1 by 6.
basically, the event is occurring simultaneously, right?
Simultaneously here, not
Yeah.
here. Okay. Okay, there is a difference. So whenever you have or, you have to add. I mean, because it's or case, right? And case is multiple case.
I had out here when you are talking about one, I could see it's only one. The face of die is only one. We have the face of one. Whereas in case of two, I mean, if you are you talking about the one single die being rolled here or two die being rolled here?
Both, right? We are considering x as a 3.
Okay, so in this case, like for example, there is a possibility if you are rolling. I mean, there is a single die can also have the three the face of 3 being coming out, am I right?
Can you come again?
I mean, if you are talking about one single die, then I could understand the total is like there are two things. If you are talking about two die, then the combination of 1 plus 2 or 2 plus 1 comes there. But when they come for the when you talk about the 3 per se, then the 2 dice also have the face of 3 there. Am I right? The occurrence of 3 is also possible. Like just because we are talking about the total here, or it's about the occurrence of 3 here. Which one we are talking about here?
No, so we are talking about both, right? So it's not about you are rolling a die, single die, you got 3 and that's all. So what is your X? You are interested in both outcomes, sum of both outcomes. Okay, you are doing the tossing the, sorry, not tossing, rolling the die simultaneously. It's you're interested in both. It's not like you roll a die, you got 3, that's all, you are done. It doesn't mean you are getting 0 on the second die, right? We are not.
Yeah.
That's
So-
not a case actually.
So it's focused on only on the total then. here.
Total, yeah. We are interested in the total of both die.
Okay, because I was just missing the question that when you had an initial discussion whether it's a single
No,
die
no.
or
So it's
full die,
not. So X denote the total score in both
both the dice.
throws. Yeah. So basically, that suppose you are considering that case. In case suppose probability will be 0, right? But that is not defined for our case.
Yeah, here other thing is like also get sometimes I get ambiguous when you're talking about throws. The throws is something to do with two different dice, or it's even the same die can be thrown twice, am I right? How do you actually differentiate?
Yeah. So basically, see, it will be clearly mentioned that whether you are throwing 2 dice or you are throwing single die twice. 2 dice single time is same as single dice twice.
Okay.
Okay.
So okay, so we should take that context. Okay,
That
thank you.
yeah. Okay, so I can see some questions.
Sir, from week 10, can we discuss few questions?
Yeah, I think more or less every question you have tested, right?
Yes. So
So
not
now-
get actually few of them.
So this is what is
Yes,
this?
sir, this
3
is the
cards are
question.
drawn in succession from a deck. Where is this from? I mean,
This
your
is
guys
from solve the class session.
solve with a PDF, right?
Yes, but I couldn't get it.
I think
So
solution.
13 question you didn't solve it.
Have
Here
gone?
the major doubt is why we are not selecting the cards. Ma'am told that we are creating a sample space of eight. Eight is the number of sample space we are creating, and
Okay, we'll see. We'll see.
the
There is doubt from question number 13. Where is 13 question? It's not there. 12 questions
No,
are there,
it's
right?
no. It's
Second
So
part.
it's
This part.
Yeah, second part. Yeah, sorry.
Hey, you have to
Second.
apply the conditional probability formula. That's all. Where you are getting difficulty? Yeah, tell me at which step you got.
So at the condition B.
Condition B. So this is saying probability X is less than 5, right? So X is less than 5 is what? What is the possible values X your random variable X will take? 1, 2, 2 to 6. Correct?
Yes.
Right? And X is less than 5 means before 5. So X may take 2, X may take 3, X may take 4.
Yes, sir.
Right? And you
Yes.
to add all those probabilities, X equal to 2, which is you can see correct PMF is 1 by 9 for probability X equal to 3, 1 by 9 plus probability X equal to 4, 13 divided by 36. You can see all the probabilities has
Yes,
been added.
got it.
But,
Yes, got it.
Yeah, so you were saying something. Yes, so number of red cards drawn in 3 draws with replacement. So it's a with replacement part, right?
So why we aren't selecting from 26 cards which are red? So could you please open the question again?
So if you're talking about 26, there's a possibility that you are talking about 22 two colors there, 13 plus 13.
See, if you see 3 cards are
So
drawn
why we
in succession from once again a deck with replacement, find the CDF of the number of red cards. See, how many red cards are there?
So may I tell my approach what I am thinking? Sir, I was making a x like 0, 1, 2, and 3. This possibility I have created, and in 0 I have selected 26 out of 0, and cross another 26 C3 and divided by 52 C3, and similarly I have done
See,
for.
why are you doing C3? That's my question. So C3, when you will do C3?
So why we are selecting, right? We are drawing the cards.
What is the meaning of with replacement?
We are replacing the cards. We are not
Correct.
removing.
Okay. One thing. Let me take some different example. Maybe that will give you the idea. Okay. Suppose I have a bag here. Okay, with let's say something. Let's say 3 red ball and suppose 4
Yes.
black ball. Okay. Now, suppose I'm drawing a ball. Okay, and in that case, suppose I have drawn. It's possible I may draw red ball and draw blue ball, right?
Yes. Sir.
Okay. Suppose in that case, suppose you are drawing without replacement. Okay. First of all, what is the probability if you will draw a red ball? What will be the probability here?
So 3 out of 7.
3 out of 7. What about drawing a black ball?
4 by 7.
4 by 7. How many remaining balls is there if you are doing without replacement?
So 2 red and 4 black.
2 red and
4 black.
what about this case?
3 red and 3 black.
3 red and
3 black.
now suppose you are going to draw again here at the second time. So again you may draw red, you may draw black.
Yes, sir.
And what is the probability here now?
Again 2 by 6 and 4 by 6.
4 by 6. What is the remaining part here?
1 by
1 red
and 3. No, sorry, 4 blue.
4 blue or black, whatever. Yeah, doesn't matter.
Black.
Doesn't matter, no problem. And in that case?
And here will be 2 red and 3 black.
So far so good. Now, what about here? You may draw red or you may draw black. What is the probability if you are drawing red here?
So 3 by 6.
And black?
3 by 6.
And what is the remaining?
2 R and 3 black. And here 3 R and 2 B.
2 black. Okay. Now let's do for 2 trial only. Now this was without replacement. Okay. Now I'm doing with replacement. So what is the meaning of with replace? You are drawing and then you are putting back again and you are redraw, right? So then what will the probability of red ball? 3 by 7. Black ball 3 by 7. If you are doing with replacement, again you will be having 3 red and 4 black.
Yes, sir.
What will the probability here? 3 by 7 again?
3 by 7.
And again 4 by 7?
4 by 7, yes.
And same here? Same in this case also?
Yes, sir.
Right. So in case of with replacement, actually, your probability is same. Okay?
Yes, sir.
Okay. So if you'll see x represents what? Number of
draws.
What was the question? Number of I don't know which question is there. So number of okay, so you are interested in the CDF of red cards. Okay, so number of red cards. Okay, so what will be the probability for drawing red cards? Then how many red cards are there total?
26.
26. What is the total number of cards?
So 52.
Okay. So what will the probability of drawing a red card?
26 by 52.
Which is half.
Yes.
Okay, this is the case. Now, how many cards you are drawing?
3.
Okay, so now if I'm writing x represents number of red cards, suppose x represents the, let me write here, x represents the number of red cards drawn in 3 draws with replacement, right? That is the situation.
Yes, sir.
Okay. What will the distribution of x say?
So 0, 1, 2,
I'm
3.
talking about distribution. Yeah, 0, 1, 2, 3 is the possible values.
Yes. So distribution means what you are
Can I
trying.
say it's a binomial 3 comma half? Would you agree with me? Because success probability is same for each trial because you are doing with replacement and it may take 0, 1, 2, 3. That's all.
Sir, it's
See,
actually from week 9 and binomial I have not
okay, fine.
Bernoulli I have not.
Okay, I'm giving you idea. That's not a problem at all. So anyway, the probabilities you have to calculate from the PMF itself. Okay.
Hmm.
Okay. Is this clear? This part? Now, so if you see, okay, let's say you are saying x may take value 0, 1, 2, and 3. What is the probability x is 0 means 0 red card, right?
So 26 by 52 then.
That this is the 0 red card.
Hmm.
Okay, what is the probability of getting 0 red cards? Okay, in how many ways you will get?
So 26 by 52.
See, 0 number of red cards means 26 by 52. That's okay. That is 1 by 2, right? It shouldn't be 3 times.
Why?
Drawing
Because
3
other
cards.
26 are black, right?
Hmm.
And 26 which composed of heart and diamond are red.
So the probability of drawing 0 red card will be only black cards will be available there, right?
It would be 26 by 52, right?
No, because here again, if I'm understanding your question right, you
Mhm.
say 0 red card, 0 red card. Then the
Correct, correct.
possibility is only 26 card black cards will be available. No red will be available there. That's the only possibility.
So what will
Did I
the
understand your question?
probability of 0 red cards?
Let me 3 cards are drawn in succession from a deck with replacement by the CDF of the number of red cards. See, 3 you are drawing with succession part, right? Okay, okay, tell me, I will come. What is the probability of x equal to 1?
So then it will be 1 red card. So
Right?
it will be 1 by 52.
Okay, what is the answer? Let me see the PDF itself. It's a 9 point, maybe that 9.9.
Sir, it's from solve with her session.
Solve with this, right? So let me see. So question, what is the question number?
So this not it was 4 days back, ma'am. So this is not the PDF. It was in white sheet,
Okay, it's on the
white paper, white background.
okay. One second, let me should be in the underlined session
That
notes.
was the peer deck, I think.
Okay, maybe I think. What is the question? Which question number?
So you could scroll down. Second last question.
Second last. Okay. This one.
Yes, sir.
So it should be 3 by 8. Yes, sir, it's written correct.
Oh, okay, okay. Understood, understood. So they are doing like this.
Yes, sir. So this is the query why they are not selecting the cards and like 26 by 52 for 0 red cards and for 1
it's the
red
same.
card.
This is the same actually. See, if you see, see three succession. See, there is no red cards means what? Right? So these are all the
All black.
possibilities, right? Right?
Yes,
All are black, right? Okay, okay. You are doing like this.
sir,
If you
I am
see,
understanding this, but why aren't we doing like this 26 by 56?
see in that case, actually, if you are doing okay, are you talking about C part or I mean this 26C3?
No, that I got it. You are saying all cards have similar properties. We are not choosing, right? That's why we are not applying their combination. Am I getting right?
Can you come again?
Sir, like you have said that we are having same probability of choosing the
Yeah,
cards
so
because they are of replacement. So we do not have to apply the combinations like 26 3 C3 like this.
yeah, in that case, actually, it's without replacement part.
So we aren't applying combination. This
No,
doubt is
no.
clear.
Yeah, yeah.
Now this one is 26 by 52. Why we aren't writing this in zero probability of red cards?
Actually, it's a 26 by 52, same as 1 by 2. So we are using 1 by 2 everywhere.
Yeah,
So
see,
in zero red
actually,
card, zero
see,
red
if
card
you are
is three
saying
black cards.
3 black cards, so what I'm trying to say, 1 by 2 raised power cube. See, what is the probability then for one black card? It's 1 by
1 by
2, right?
2 into 1 by 2 into 1 by 2.
1 by 2, right? So that's why it's 1 by 8. See, this probability of this is about a red card. It's not about if you are right, if you write 2652, so you are trying to write for one card, one black card, right?
Yes, sir. Yes.
Right. So for 3, it will be cube, right?
Yes, sir.
Okay. So if you have one card, one red card, this means what? It can be red, black, black, or probability of black, red, black, or probability of black, black, red.
Yes, sir. Yes, sir.
Right. So this will be, what is the probability of getting a red card? It's half, black card half, half, half. So basically 1 by 8 plus 1 by 8 plus 1 by 8, which is
3 by 8.
3 by
that's the approach. Okay.
So again, I have to reconfirm. If we are replacing the cards from the deck, so we are not applying the combination in it.
Yeah. So in case of combination, actually what happens in case of combination, if you see, in case of combination, the success probability is not same actually. Okay. So in case of combination, basically this is not same. Basically in case of combination, you are not worrying about order, right?
Right.
So without order. Okay. So
Yes.
that's why you simply do 76C3 and 52C3, right? So here you are not worrying about. Here if you see, we are going to consider the order, right? In case of combination, if I have drawn red, black, black, okay. So that's the case. Means we have drawn one red and two black. That's all. We are not worrying about order. Like, but if you see in case of this, in here in this particular question, we are worrying about the order, right? If
So
order matter.
again, so again, a doubt came. Why we aren't using that P instead of C permutation?
No, 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 no. So that's for draw. See that in that case, then see this will tell you in how many ways you can select, right?
Yes.
You are not ordering here. See, I'm worrying about this order of see. Okay, tell me here. If you are right, first of all, if you that's the actually. So if you are right, what are the possible cases for this? How many ways?
Means how we can arrange this? So
Total 3
second the position of R.
basically total 3 ways, right?
Yes, yes. Sorry.
And 3 into what is the probability of all this?
This is 1 by 2.
1 by 8.
1 by 8,
Right? So that's the way, right? That's the way. So if you are thinking to do 26 P2 and 52 P2, okay, can you try this one? Whether it will give you the same answer or not? Okay, suppose you are doing like this. Okay, so this will be 26 factorial divided by 23 factorial divided by 52 factorial and divided by, and this is not the way actually. So actually here this is the case. I mean, you if you see this is the different one. If I am just interested to draw a single red card, and which is I can do 26 divided by 52, favorable case divided by total case, right? And if you want to do this case, so in this case, I'm not worrying about order. See, whenever you are doing combination, so in case of combination, first of all, success probability will not be same. Okay, have you seen the hypergeometric distribution?
Sir, success probability means we are.
Means suppose here I'm interested in drawing a red ball, then that if I draw a ball and that is red, that is my success. Okay. So here if you are doing without replacement, then if you see this probability is different, right? This probability is different. This here this is 3/7. Here this is 2/7 or 2/6, and here for
Yes,
black it's 4/7 and for black it's 3. It getting changed, right?
mostly comes
While
with a replacement.
yeah, so whenever it's with replacement, the probability is same. Okay, and it's without replacement, then you have to go with this combination. You can go with the combination part because we are not worrying about the order. We are just trying. Okay,
Yes.
something I can see.
So then permutation one we
No,
were.
I think I need to check that permutation part. I'm not sure, but combination is for whenever you not worrying about order. You have to just doing without replacement part. So without replacement means you have just simply selected, see, this R B R anything, right? Means you, sorry, R B B means you have one red ball, that's all, you are done.
Yes, sir.
Okay.
Sir, I'm a bit confused in this only permutation and this
See, permutation is just about
or
whenever you, so, okay, let's talk about this number of ways, right? Okay. So, okay, I do not go in this part. It will make confusion actually. So, permutation, okay, permutation is clear or not? We are worrying about order,
yes, sir, this is clear. The basic
and
definition is clear. But
and
then
combination is without order.
Sir, so sometimes in a permutation we apply 26, suppose
Hmm.
26 P2 and for example divided by 52 P2, and
Hmm.
sometimes we are saying that simply it's 1 by 2 without applying permutation. So this difference I'm not getting how the we could understand the language on how to apply
Which
something.
one? Which one? Which one? I can you come again?
In this
Hmm.
question only, I am confused between if we have to apply permutation and counting the number of ways, or we have to directly go to the basics of probability, like 1
Hmm.
by 2, and then we have to multiply. So this I am not getting. The word will be the language of the question, so we would be able to understand.
See, whenever it's all about one thing, I can say, see,
Mm.
permutation is okay. Whenever you are doing permutation, permutation is about arrangement, right? So here you will do, you can do, that's not a problem, but you may get confused. Okay, suppose for three parts, R B is there, right? What are the possible permutation in this case? In how many ways you can rearrange? Okay, let's R B B something like that. What was the possible arrangement?
3.
Only three.
Mm.
Okay, how you are getting dash three? You can see these two are repeated, right? If you see there is something repeated, I will do 3 factorial divided by 2 factorial into 1 factorial,
Yes.
and that will give me 3, right?
Mm.
So one way is you can do like this. Okay, basically you can write this 3 into 1 by 2 cube again. Oh, sorry, 1 by 2 cube for all probabilities. You can do like this. So I think if you are getting confused, see, it's not about if it says uh, let's say if it says drawing let's say two red balls, but actually I think I need to think a bit. It there should be clearly mentioned you are drawing two red ball and first two are red. I mean order is mentioned. Are you getting my idea?
Yes, sir.
Okay, so order will be mentioned. If it is clearly mentioned, you have to draw, let's say in a box there are 10 red balls. Okay, not red ball, 10 total balls, and
Yes.
some, let's say 3 are 4 are blue and 6 are red. Okay, I'm
Yes.
saying I'm doing drawing a sample without replacement of 3. Okay,
Hmm.
for example, um, uh, 3 balls samples, then in what is the probability of drawing 2 red ball?
Two red.
Hmm.
Yes.
Okay, how will you do then?
So give a minute. So three balls and three draws we have to take. So for first draw, we are selecting. Uh, so I'm not getting means 2/6.
Why? And I have mentioned basically in case of without replacement.
Two are red. So
Okay.
3C2, yes, sir. So 3C2. And
Mhm.
then 4C1, right?
Mm-hmm.
Then divided by 10C3.
Okay.
Is it correct?
See, I said I have 10 balls total, right?
10 balls.
And 4 are red and 6 are, let's say, blue.
Sir, six are red and 4 are blue.
Okay, let's say 6 are red and 4 are blue.
4 are
Vice
blue.
versa.
And
Okay.
3 draws. And
Without replacement,
acha, yes.
right? I'm
And
doing without replacement.
and you have said two we have to give red. Means two should be red. Two red balls we should have. So I am saying that we could select 3C2 into 4C1 divided by 10C3.
Okay, suppose I'm saying X represents the number of, let's say, red ball. Okay. Uh, Drawn. Now, if X is, what is probably X equal to 2? I'm doing without replacement. That means I can draw any uh, 3 balls out of 10.
10, yes.
And what is my favorable case? So this is total case, right?
Yes, sir.
Okay. What is the your favorable case? It will be. Let me write clearly. It will be 4 blue, 6 red. It will be. Tell me.
6C2.
6C2 and remaining will be
4C1.
say you are interested in without replacement, right? In case of without replacement, actually your probability will get changed, right? And that permutation part, I think I need to look at that part. Okay. So one thing I can clearly say, if whenever this part is clearly mentioned, right? So you can do like this. So I
And
mentioned this
if we are going with replacement, then only simple probability we have to apply.
simple probability basically. Yeah, you can go with like this. Okay, because in that case, this if one more thing, if all trials are independent, you can go with the binomial also.
So are you agreeing with me if I am saying that we are applying permutation much lesser in probability?
It's not that, it's not the case actually. So we are not directly writing the formula. See, if you see this part, see, one red and two black. Okay, one red and two black. In that case, we are taking the permutation indirectly itself. One way is I can write like this. I can consider all the cases and then uh, and then I can calculate this probability plus this probability plus these probabilities. Correct? This is one way. Another way you can think like this from the smart approach, which you have done in case of in week 5.6. What is the total number of arrangement you can suppose this is large. I mean, 4 or 5, something like this. In how many ways you can arrange something like this? 3 factorial divided by 2 factorial into 1 factorial, which is 3. If I will solve 3 into what is the probability for each case? It's 1 by 2 raised to 4. So it's a 3 by 8. This is one way. I mean, suppose you are doing some 5 successive draws. Let's say this something like this. Okay. Then in that case, you are not going to consider. You are not going to do all the order, right? I mean, if you consider, you may miss the order. Yes or no?
Yes, sir.
So then, what will be the your approach? So this will be how many letters are there? 5 factorial divided by 3 factorial into
2 factorial.
2 factorial. Whatever the answer into 1 by 2 raised to power 5.
And this the we are doing like this. This is permutation or combination, or this is another thing that we are
This is
doing?
the permutation part, right? So this is the permutation because you are considering about order, right?
Yes, yes.
Okay, that's the way. So you are say that directly and all you can see more deep way, but this is the another way you can look into.
Yes, sir. Yes. Thank you, sir.
Okay. So I think there are some questions. Activity 10.4.
So 10.3 as well.
Someone is saying something I'm not able to hear. I can't hear you. If anyone can hear, please. Yeah, which question?
Sir, can we discuss one by one all questions?
No, miss, if you are doing like this, I will not discuss. So that means you haven't tried, right? That's the case?
Yes, sir, I couldn't.
No, so please try it out. So I can discuss, I can give you everything, and even you can find out the solution video. Okay, so if you have a specific doubt, I will discuss for sure. That's not a problem at all.
Activity question solution videos available or not?
Yeah, it should be there, right? On the computer itself. If you go under the supplementary content, you can see activity
Well,
solutions
we are
video.
having the PDFs, not the solution videos.
It's a video.
So could you please share your
Yeah, my screen is visible to all of you. So you can see activity video solutions. You can click here, you will get a whole playlist. Okay. Yeah, so any specific doubt I can discuss, that's not a problem. So see, I can discuss the whole question. See,
So these are very,
nah.
very small questions, just need the idea.
Okay, I will give you the idea. Then that's the case, then I will give you the idea. Okay, just try it out. Okay. So see, why I'm saying like this. So if once you will put efforts from your side, right, you will gain something more. Okay, so I can solve, I can give you all the solutions. That's not a problem at all. Okay, so which of the following statement is true? So first of
So
okay, tell me.
question one is okay. So from question two.
Okay, if you want to do the solution from my side, okay, what is the expected number of outcomes for 10 biased dice is given, right? And it is asking what is expected of some of the outcomes. Okay, so first of all, you can apply the concept, right? First of all, you have to add all those things. That's all. See, we know expectation of x1 plus x2 is same as expectation of x1 plus expectation of x2, right?
Yes,
If I have to write expectation of x1 plus x2 plus x3, then what else can I write? Can I write expectation
so
of x1?
separate, yeah.
Right, that's all. So you have to add all those expectations. That's all because this is expectation of x1, expectation of x2, expectation of x3, x4, x5, and so on. These are the values. That's all.
Okay, okay. So sir, actually that was I was finding difficult to translate English into.
Okay.
Yes, sir, got it. Thank.
Okay. So I'll discuss the second question. Others, I think I will leave on you. Just try it out once from your end. If still you are not getting, then I can discuss. That's not a problem. So next question, in a software office, there are 20 junior developers, of which 8 are men and 12 are women. So there is a office, there are total 20 persons, out of which 8 are men and 12 are women. So 8 are men and 12 are women. Now, if 5 junior developers are to be promoted to senior level, what is the expected number of women in the promoted developers? So let's say I'm drawing, not drawing, basically 5. These are the sample, I can say. Yes or no? Which these are developers are to be promoted.
So 5 people are to be promoted. So
Out
how
of
are we
this,
going to?
out,
Yeah.
out of these 20 people, right? Now,
Yes.
so if what is the x represents, you see x is the number of women, right? Number of women promoted to basically the number of women promoted to next level, senior level, something like this, right? So what is the possible values your x can take?
So 0, 1, 2, 3, 4, 5.
Right? 0 women, there may be 1, 2, 3, 4, right? Now, what is the probability of x equal to 0? 0 women. First of all, what is the total case?
20, sir.
Total case of promoting I have to
25.
25, right? You can choose any 5% out
Yes,
of
sir.
20, right?
Yes, yes.
Now, what is the probability of 0 women? 12C 0
12C 0.
and 8C all are men, right?
Yes, sir.
Then what is the probability of there is only one woman? First of what is total case? 20C5 and one woman means any woman out of 8 into sorry out of 12 and then 8C 4 men and whatever the values will be there. Understood? Similarly,
Yes,
you
I
have to
got
do.
it now.
And
Yes.
there is something called hypergeometric, which you will learn. This is the actually example of hypergeometric. So in case of hypergeometric, this represents the capital N, this represents the small m, and this will be capital N minus small m. This is the sample. So expected number of x is nothing but n into m divided by capital N. So small n we are drawing sample of 5 and m is the favorable where it's for women and divide by total is 20. So basically answer is 3. Yeah. So answer is 3. So this is the one way if you know hypergeometric, but if you don't know hypergeometric, that's not a problem. If you will solve like this and at the end, if you what you have to do, you have to apply the expectation formula, right? What is that? Summation of x into probability x equal to
X.
x.
Yes, sir.
So if you'll apply, you can see this is you will get the same answer. Okay, so that's the way. Just what you have to
Yes.
think basically. What is the possible outcomes your random variable can take, and what is the corresponding values probabilities associated with each values of your random variable. Okay.
Yes, sir.
Okay. Anybody? Anything else? Okay. Basically, how did you find these? Yeah. Good. You are not audible to me. You can write in the chat box. How did you find the content overall?
So week 10.
Overall means stats. Yeah, week 10 or
Sir, actually, it's easy. It's not that difficult, but we have to get concept of like we have to thorough everything together and then we'll be able to solve the questions.
correct.
And I have a request. Already I put to Swati regarding this. We actually didn't get that instructor, I mean, the Professor Mohan's lecture slide that she said to upload after the session in the supplementary, but till now it's not been uploaded.
Which slide?
The revision session, the one that Professor Usha Mohan.
That same is PPT is same anyway. That's not a problem at all. So the PPT which ma'am is using the lecture actually, it's the same thing.
Yeah, I do understand, but only thing is like if it's a kind of what you call downloadable thing, we can actually download it, but we have to go through the video to go review things. That's the reason I'm asking for.
No, it's not about video. So you can go under supplementary content.
Yeah.
And you can find. Let me show you. I think
it's not
there.
available to my knowledge till now.
No, it's there. Yeah, it's there, right? Quiz 2 revision session by Usha ma'am dot video. It's there. Okay. Or else the simple thing, if you go under supplementary content, right? And there is something called this part, lecture PPTs. So this lecture PPT is same which means.
Yeah.
Okay, so which question I think she had doubt.
So 10.4 we can go now.
1 second. 9.3 fourth question. Okay, a random variable x is defined as the length of hypotenuse of the right angle whose other two sides. Okay, any one of you wants to explain this one? Those who have done.
Yes, sir, I have done.
Yeah, please go ahead.
So we are doing it by roll of dice. So the values it can take just one. This is 9.3 question.
9.3, question number 4. Now, anyone of you, if you want to explain
Yes,
that.
sir. Sir,
18, sir.
so we are finding length of hypotenuse and whose two sides are determined by roll of dice.
Correct.
So sides can be 1, 1, 1, 2, or 2, 1, 2, 2, 2, 3 up to 2, 6, like that.
Basically, there are total 36 outcomes.
Yes, sir.
Okay, yeah.
So, sir, when we have, so we can have total values as 6 or 5, 4, 3, 2, 1, and that sum is coming out to be 21.
Yeah, there will be some common also, right?
So
Total
it is
outcome.
repeated.
Yeah,
Yes.
total outcome is 36. I mean, if you roll a die twice, total outcomes you will get 36. Out of those 36, 5 will be common, right? So 5 will be common means this is what are those common part?
Repeated actually. It will be
Yeah, if it's the right angle trend, so basically 2 1 will give you the same answer as 1 2, right? Yes, and what are those other possibilities?
So it's like 1, 1, 1, 2,
Hmm.
and then up to 1, 6, we have all the 6 possible.
Correct.
Teeth.
All the 6 possibilities. Yeah, correct.
And then 2, 1, 2, 2. That way we have only 5 possibilities here.
Okay. Hmm. See, basically 1 1, 1 2, 1 3, 1 4, 1 5, and 1 6, right? Then 2 1, 2 2, 2 3, 2 4, 2 5, 2 6. Correct? Now, similarly, if you see 3 1, 3 2, 3 3. So after this diagonal, right? It is so this is here, right? This is 3 1 is here, 3 2 is here, right? 3 3. Then here it will be 4 4, and then 5 5, and then 6 6. Okay, so basically 3 3, 3 4, 3 5, 3 6, 4 4, 4 5, 4 6, then 5 5, 5 6. So how many cases are there? 5 6, sorry, 6 5, 11,
5, 4, 4, 3, 2, 1.
11, and this is 15,
Yes.
318, 321, right? So there are total 21 outcomes, right? So your x will take 21 values, right? Because it's going to add this. How will you compute this hypotenuse? Square root of?
Square root.
Root of basically this base and another two
Base and
parts, right?
height. Yeah.
Base and heights, right? That will give you the 21. Okay. Now that's the correct. Whether now tell me whether x is discrete or continuous.
They're discrete.
Why not continuous?
Because it's a roll of dice, so we are giving input as discrete only. So output cannot be
Also,
continuous.
the continuous is something it taking continuous values, right? You cannot count, right? That's the case of continuous. Yes or no? X is something if discrete means it's a countable, correct? Okay. So, and whenever you are, if you draw a real number line, it will take distinct values on a real line if it's discrete, right?
Yes, yes.
And if it's continuous, it may take any value between two values, right? But here it's a discrete because if it has x has 21 possible outcomes, then if you draw a real number line, so it will take only this 21 distinct outcome, right? It is not going to take any value between this and this, any value between this and this. Are you getting my
Yes,
point? So it's taking distinct value, this 21 distinct value. Okay, so that's why it's a discrete. Okay, it's a countable also. Right? Okay.
Yes, sir.
Yeah. Anything else? Yeah. Anybody? Anything else?
So in 10.4, can we take question number 3?
10.4. So number 3. What is doubt? What is your doubt here? Variance of a random variable can be negative? Yes?
No, this cannot be negative.
Okay, correct. If the variance of a random variable is 0, then the cardinality of a random variable is 1.
Yes, sir, I want to understand this.
Okay, so random variable, okay, tell me, see, if random, what is the cardinality meaning of a random variable?
So the values that it can.
See, cardinality of a random variable is 1 means the random variable is taking only one value, right? Yes or no?
Yes, sir, if cardinality is 1, that means random variable is taking only one value.
One, right? So just I'm saying x is taking value 1. I'm saying what is the variance of x? That means I'm asking what is the variance of 1? What is the variance of a constant?
Constant
0.
only, so 0. Yes, sir.
That's all. As size and increases of the uniform random distribution increases, variance increases. Yes or no? Because if you see in case of uniform distribution, what is the variance of uniform distribution? Anyone can tell me the formula?
Expected value of x square minus x
No,
whole
no, I'm
square.
not. I'm not asking in general formula. See, if you see variance of a discrete uniform, so what is the expectation of in case of discrete uniform? It's n plus 1 divided by 2, right?
Yes, sir.
And what is the variance of if this is the case, expectation of x square will be 1 square, 1 by n will be common, plus 2 square plus so on plus n square. So basically this will give me n into n, basically not n plus 1 into 2n plus 1 divided by 6. So variance of discrete uniform will be expectation of x square, that is n plus 1 divided by 2n plus 1 divided by 6 minus n plus 1 divided by 2 whole square. So after you will solve this, you will get the variance of discrete uniform. So it is saying, if you see n is in the numerator, right? Correct. So it depends on the value of n. If n is increases, the variance will increase. That's all. Yes or no? If
Okay,
n is
sir.
5,
Okay,
you
sir.
will get
Yes.
some value of variance. If n is 6, it will increase. Correct.
Yes, sir.
And the variance of a Bernoulli random variable is maximum when p is equal to 0.5. Yes or no? So basically, what is the variance of a Bernoulli random variable? P into 1 minus p. Yes, no. Can you recall variance of Bernoulli random variable? What is the Bernoulli random variable? X will take value 0 and 1. What is the probability? 1 minus p and p. Right? What is the expected value of x here? 0 into 1 minus p plus 1 into p, which is p only. What is the expectation of x square? 0 into 0 square into 1 minus p plus 1 square into p, which is will be p. What is the variance? So variance of x will be a expectation of x square minus expectation of x whole square. That is p minus p square. So p I can take common, p into 1 minus p. That's the variance of a Bernoulli random variable. Okay. So when you will check maximum thing. So from the mathematics, you know, I have to differentiate and I have to equate with 0, right? So if you differentiate this with respect to p, so what will it will be 1 minus 2p. If I will equate it 0, what will the value of p here? So p hat will be 1 by 2. That's all. And if you, okay, another thing, when it is maxima, if you see the second derivative, so second derivative will be -2, which is less than 0. So whenever less than 0, this will give you the maxima. So this variance will be maximum when p is clear.
Yes, sir.
Yes.
Okay, that's the basic thing. Okay. Okay. Anything else? Anybody?
10
See, I think then you are not listening me carefully. See, what is the variance of random? It's saying 1 to 20, right? And what is this? I just discussed few seconds ago. This is just a variance of, if you see discrete uniform. So what is the discrete uniform? 1, 2 up to n. It will take value 1 by n, 1 by n, 1 by n. Right? This is probability. So this is expectation of x. Instead of n, what is the case? It's a 20, right? So what you have to do, just substitute 20 here, 20 here, 20 here, you will get the answer. Understood? You can see it's a discrete uniform, right? Instead of n, we have value 20. Clear? Okay. Okay. Anybody? Anything else? Yes, Saika.
So, sir, can you tell me what's the process of grading for the activities
From your end or from our end?
from your end?
Okay, that we will do. That's not a problem at all. So
So
there is some
actually,
policy. See, there is some policy that we are doing internally. So that's not some. So don't worry about the marks given by peers. Okay. So final marks will be given
okay,
from our
sir.
side. Okay.
Yeah, sir, but there's a problem.
Hmm.
I got 89% in my activity two,
Hmm.
but sir, I did everything like to the word, to the letter which was mentioned in
So
the
89 is from given from our
description
side.
of activity.
89
Yeah,
is
yeah,
from our
yeah.
side. And what is the peer
Yeah, yeah, yeah.
marks you are get? See, if you read the description part, so
Here I
whenever it,
got.
hmm,
Hmm,
yeah,
I'm
tell me.
listening.
Yeah, go ahead, go ahead.
So peer, I got I got mixed reviews actually. Two people gave me 60 and two
Yeah,
gave me
that's all.
100.
So the thing is, okay, let me tell
And
you. Okay, okay, let
so
me tell you
the
the.
two people who gave me 60, they are
Hmm.
saying that the charts were not present. Now,
And
here's the twist. One of them said charts were not present. One of them said that the variable listing, like the
actually,
other.
that is the issue. So I would request to everybody. So please do the honest review. Okay, if you don't want to do, do not
No,
do the extra
what I
activity.
think
Okay,
happens is
let me
that
finish
Google
first.
Sheet. Okay,
Let me
sir.
finish first. Okay, so it's a general announcement to all. If you are doing extra activity, please do honestly. Otherwise, don't want to. This is just a extra. So this marks will be added only if you will pass the course. So if you will not pass the course, your marks will not be added. Okay. So this is just a extra. It's nothing related to out of 100. If you don't want to attempt, even you can get 100. And this is just extra practical point of view. Another thing, please do honest review. Okay, if you are putting some effort, you will learn something. Suppose I'm checking someone else activity, I will get to know, okay, this is the way something can explain in another way, or this is another way, something like that. Okay, so it's a request to everybody, please do honest review. If you're not interested, do not attempt extra activity. That's a clear message from my side. Okay, so otherwise there is no point. If you are interested in marks, you'll get marks. Okay, you can get marks from quizzes and from assignments and all, as per the other grading policies. The extra activity is just a extra. That's the name, extra. It will give you some practical idea how you can perform on the same thing which you are learning, the same thing on a real life data. Okay, so it's a request to everybody who's those are doing peer review, please do honestly. Okay, it's a extra thing, right? That's not a problem. It's okay. Yeah, please go ahead. So one more thing regarding this evaluation and all. So we have a script actually. We are checking if there is too much discrepancies the given marks by the other peers. So we are those activity we are checking from our side. Okay, that's no problem. So that 89 marks is the final marks. Okay, so that's there is no biasness in the marks given by us. So we are taking some weightage of your activity, and we are taking some weightage how many peer reviews you have done for others also. So there is weightage for that part also. Okay, that task. Okay, is this clear?
Okay, so but will I get my marks back? Like I got 89, I definitely deserve 100.
So Saika, it's not about 100 or something like that. So see, two peers gave you 60-60, right?
Yeah, and two gave me 100, but I didn't get the fifth peer review. Still
It's fine.
says
It's fine. That's
waiting.
not a problem. So 50-60. Okay. So basically, we are taking some weightage from the marks given by peers, and some weightage the peer reviews you have done for others. Okay. So don't worry about it. Anyway, we are not taking all. I think I need to check the. I'm not sure about the grading. Anyway, it's just out of five. Okay. Don't worry. At the end, we will take the average. That's not a problem.
So but the average goes down, no, if I get 89. If I get 100, then the average
So
remains
that's the
good, but
final,
it,
Saigas. Saigas, we can't do anything. Okay, so that's the final. The marks given by from our side, that's the final. Okay. So if there is any discrepancy, we will check. Okay, that's not a problem. All right.
And sir, sir,
Hmm.
in my case, I have gotten like 40, 50, and 100 marks in activity 3.
Hmm.
But like I have done correctly and for the same format given in the example of the activity.
Hmm.
So will I be,
It's not a
will the
okay.
course
So
start?
activity three peer review due date is not over. Okay. So after the due date will be over. Once the due date is over, only then we can comment something. So basically, once the due date is over, only then we are getting the data.
so in case of activity 3, there was a mistake from your end, right? Like the
Okay,
only two
so
options were
okay.
available.
One second, let me be very clear. So that was the mistake from our end that I agree. That was some technical issue. But we send one announcement to everyone. Not start the peer.
But sir, it's their fault. We didn't start the peer review.
So I didn't get that announcement.
Okay, so I think due date is 13th, right? If I'm not wrong.
I haven't checked. So.
Yeah. See. Okay, so now
Yeah,
you
due date is 13.
now you guys are 100 blaming 100%. See, I agree that was the technical issue, but at least no one is I mean at least very few are reading the announcement or mail which we are
Actually,
sending.
I had already done two reviews right at like
Hmm.
12 a.m. That when the peer review was live.
Hmm.
So within 10 minutes only, I did two peer reviews, and I thought that this must be a problem, so I waited for the other three.
Okay, no problem, no problem. That's not see, Saikat, actually once the this we will come with some alternate way. Okay, that's not a problem. See, no, don't worry about these things. Okay, if there is any issue, we have solution for that. Okay, that's not a problem. Okay, don't worry, you will get 50 marks or something like that. It there will be what to say justice for everyone.
Adjustments.
Yeah, adjustment. There will be alternate way. Okay, that's not a problem.
Okay.
Okay, all right.
Yes.
Yeah. Okay. Anything else?
No, sir.
Okay, all right. Thank you.
Thank you, sir.
Thank you. Bye.